Hi and welcome to today's Bare Basic lesson on solving simultaneous equations. We can have systems of simultaneous equations which contain two or more equations that can be solved using the same variables. Now in Year 10 and in Maths B, we will generally only go to two equations and two unknowns. However, for those of you who are doing Maths C, you will go further, but you'll also learn a different method of solving simultaneous equations. So this video concentrates on the ones that you'll learn in Year 10 and will use in Maths B. So generally speaking, simultaneous equations can be solved in two ways. The first is graphically. So what we do is we take our two equations that we've been given and we graph both of them on the same Cartesian plane. Where the lines intersect is a point that meets the conditions of both lines. That is, you can put that x and y value into either equation and it will be correct. So the point of intersection, that key common point, is the solution to the simultaneous equation. If you have time and if you have a graph, this is by far the easiest way to solve your simultaneous equation. The second way, and the one in which this video concentrates on, is to solve algebraically. And there are two techniques that we can use for this: the substitution method and the elimination method. So the substitution method is where the value of a pronumeral from one equation is rearranged and then substituted into the other equation. So we go from having two equations and two unknowns to one longer equation with only one unknown, and you know how to solve that quite simply. So here's a worked example, and it's just a simple example. I'll do a couple of more complex ones and post those in a video just on the substitution method. So here's our simultaneous equations. Y equals 3 minus x and y equals 2x plus 1. So we want to know what values of x and y will be true for both of these statements. So step one is to label the equations, and when we're doing anything with simultaneous equations, it's really important to label your work to communicate clearly what you're doing. So we're going to call y equals 3 minus x equation 1 and y equals 2x plus 1 equation 2. Step 2 is to substitute the value of y from equation 1 into equation 2. Now in this case it's quite simple because we already have both equations in terms of y. So instead of saying y is equal to 3 minus x and y is equal to 2x plus 1, what we can say is 3 minus x must be equal to 2x plus 1 because we know that our y values are the same. Step 3 is to solve for x, and I have my working here. So you can see what we do is we get all the x's over to one side and all our knowns to the other side. So I'm beginning with taking 3 from both sides, and then I'm going to add 2 to both sides and so on, and we end up with x is equal to 2/3. But that's only half of our answer. After we do this, we need to substitute our x value back into the original equation to get y. So what I recommend is to use equation 1 and to substitute our value back into there. So we now know originally it was y equals 3 minus x, and we know that x equals 2/3, so we get y equals 3 minus 2/3, so y equals 2 1/3. So our solution to the problem is x equals 2/3, y equals 2 1/3. Now, what I would do then, just for your full communication marks, is I would actually, using equation 2, I would substitute in this x and y value and show that that indeed is true, and that becomes your check that you have done the right thing. The second method that we're going to go through quickly is the elimination method. This means that we're removing or eliminating a variable from our set of equations. And here is our worked example. Once again, I'll do more complex worked examples in a separate video purely on the elimination method. So we're being asked to solve the simultaneous equations 2a plus b equals 6 and 3a minus b equals 4. Step 1 again is to label the equations. So we're just going to label those 1 and 2 in the order that they were written. Now, with the elimination method, step 2 is to look to see if there are any pronumerals that we can easily eliminate. And what we do to eliminate is to add or subtract the equations together. So in this instance, you can see that we've got a plus b in our first equation and a minus b in our second equation. So if we were to add these two equations together, we would actually eliminate b altogether. So let's do that. So we're going to add the equations. So we have 2a plus b equals 6 and 3a minus b equals 4. When we add them, we add each term separately. So overall, we have 2a plus 3a, which is 5a. Our plus b minus b gives us 0, hence it's eliminated, and 6 plus 4 is equal to 10. Step 4 is then to solve for our unknown, which in this case is a. And a is equal to 10 over 5, which is 2. Just as with our previous example, our final step is to substitute the value for a into equation 1 to get b, because at this stage we've only got half an answer. So 4 plus b, because 2 times 2 is 4, plus b is equal to 6. So by solving that, we get b equals 2, and therefore our solution is a equal to b equal 2. And if we were to substitute those values into equation 2, we'd get 3 times 2 is 6, minus 2 gives us 4. So indeed, we know that that is correct. If you have any questions, just ask me in class or email me. This has been your Bare Basics lesson on solving simultaneous equations algebraically. It's just a very brief introduction, and there are further videos that you can look at to clarify and to go through some more complex examples of using this method to solve simultaneous equations. Remember, the aim of Bare Basics is to make maths more bearable.